Hello everyone, welcome to the next module. In this module, we will be doing our actual coding exercise. So if you are getting enrolled to this particular course directly, then you might not be familiar with Google Colab. I recommend that you take a few of the other courses that we already have in Research Goal, which is Python programming for biotechnologists, or there was another course that is data analysis, AI-powered data analysis in Python for biotechnologists. All those courses are really good, and they will provide you the fundamentals of the programming in Python, and your life will become much easier for this particular course. All right, so without any delay, let's start with the coding exercise. Before that, let me tell you just the background that what we have covered so far. That in this particular course, we have covered that what are machine learning algorithms, how they work, how we can design our own project, how we can quantify the output that we get from machine learning models, how we can determine what is the quality of our model. All those things we have already covered. So now it's the time that we apply that knowledge and develop our own machine learning algorithm and on a particular data set, which is obviously related to cancer biology. In this one, we will be focusing on breast cancer classification. Breast cancer is one of the most common cause of cancer affecting women worldwide. Early detection and accurate diagnosis are really crucial for the effective treatment. That's why our model is going to help us identifying whether the tumors, they are malignant, or whether the tumors that we are getting from patients, whether they are benign. So it's very important that the physician, they decide what kind of treatment they should be taking. We will be using machine learning, and machine learning techniques, they can assist us, medical professionals in classifying the breast cancer data set, whether it is malignant or whether it is benign. Right? There are few characteristics that we are going to determine, and then based on that, we will decide whether that particular sample belongs to this particular class. Anyways, I'll tell you everything one by one, so don't get overwhelmed by the information. We'll go very slow. First, let's start by getting the libraries, and I think if you have done those courses, we start with importing NumPy as NP. Right, so we know that we need NumPy for numerical computation in Python. If we want to do numerical computation, NumPy is the library that we work with. Second one is pandas. So we get the pandas as PD. It's also automatically suggesting me a lot of those libraries, but I'm going to go slow, and one by one I'm going to get the libraries. Another one is sklearn. So sklearn is the library where we are going to import a lot of different things. Specifically in this one, we will import sklearn.datasets because we need cancer dataset, and all those datasets, there are a number of datasets present in sklearn that you can use for training your model. So that is why we are getting this library. So that I hope this is understood, that why we are getting sklearn.datasets. Next is obviously, if you remember, I told you that we need to split our data into test and train data. We have to train the data. We have to have the data that we can use to train our model, and we also need to have the data that we can use for test our model. And this is the library we will be getting, so that we can split the data that we are going to have. Otherwise, it will be difficult for us actually to divide, and what kind of division we need to have. Everything is being taken care by sklearn.model selection, and we are getting from sklearn.model selection, we are getting import train underscore test and underscore split. It's going to split our data. Okay, what else? If you remember, we talked about linear regression, and that is what we are going to also get. So from sklearn.linear model, we are going to get logistic regression, not the linear regression, right? So we are going to get logistic regression that I've explained in my module also. So this is how you are going to get that particular model. Let me zoom in a little bit so that it's clear. Okay, next is we need to have the accuracy score of our model. So this also provides us this opportunity that we can calculate the accuracy score by sklearn.metrics. So in that one, we have option to calculate accuracy score. So we are importing that. We will apply all those things on in our data. Next is we are also going to get the matplot library. I think I should keep it after the pandas, because this is something which usually goes together. For example, NumPy, pandas, matplotlib, and there is Seaborn. And I've created, in my data analysis module, I've used all these 4 libraries and explained everything about these libraries. So I'm not going to do that here. I hope you have taken that course. If you haven't, then please go and take that course. It's going to help you in data analysis and create amazing plots and make your life much easier if you're a research student. All right. Next, we are going to get another library, which is import standard scalar. This is very, very important because this is, when we have the data, we need to do normalization. And I've already talked about normalization and all. And that is why we need sklearn from sklearn pre-processing, we import scalar, standard scalar. It's going to help us in normalization of our data. And then we also need to evaluate our model. For that one, I have this code, and this one is going to get us the library that we need for model evaluation. Remember, confusion matrix, we need to calculate classification report we are going to get. So all that information regarding our model quality is going to be generated by this particular part of this code, right? So it's very, very important that whatever you are getting, it should be clear. All right, so this is what we are going to get for our machine learning exercise. In this one, we will be creating the entire model. I'm going to delete that the cell. All right, I hope that is clear. Now let's move on to the second part of this coding exercise. In this one, we will be doing data collection and processing, right? So we need to have the data, right? We have already imported the library. So first point is to load the data. So what we are going to do is we are going to get the data from breast cancer data set. So this is the code, and I'm not going to spend time in typing this code. I'm just going to explain that this is what I'm going to create, and this is from where I'm going to get the data set, which is sklearn.datasets. That is what we have actually got from here, right? So after this, which kind of data set you want, which is load breast cancer data set. Okay, so let's start running the cell number 1, and what it will do, it will run all these codes sequentially, and we'll get all the libraries that we need. So we get a green check mark, so that means it's good. Now let's run the second one. In this one, as you can see over here, we have successfully imported the data set. So what we are doing in this case is we are using the built-in breast cancer data set from scikit-learn. This dataset is well known. It's already cleaned and processed. So we are not doing a lot about data processing and cleaning, and we should not be doing that. If you are creating your own model with the raw data, you need to process and clean your data first. That is why this is clean data, and it's ideal for learning different kind of machine learning techniques. What it contains some features that we get from digitized images of breast mass samples. So that is already there. Now, why don't we see our data? So to see the entire description of the data, what I'm going to do is I'm going to, this is the data set, as you can see over here. Now we have that variable assigned. And if I type this .tsecr, which is description, immediately, let me run this. Immediately what will happen, I'll get detailed information about this particular data set. So let's start from the beginning. As you can see, this is the title, and what you have is the description over here. This is breast cancer Wisconsin dataset, and dataset characteristic. What you have is number of instances. You have 569 patient samples, total patient samples. How many attributes you have means different parameters. You have 30 different parameters. So every sample will have 30 different characteristics that you are having. And what are those characteristics and attribute information is given over here. I cannot go to all those 30, but I can tell you a few of them, right? So domain knowledge is very, very important when it comes to machine learning. So someone who is a physician was able to actually identify what are the different attributes that you should have. For example, what is the radius of that particular tumor? That means mean radius from the cancer to the point of perimeter. Next is texture. What kind of texture of that particular cellular mass is? Because when patient go to a particular hospital, they will have those tumors, and tumors will be taken out, or they will be captured, and from that the analysis was done. As you can see over here, texture, standard deviation of the grayscale value, perimeter, how much perimeter is there, area, smoothness, how smooth or rough the sample was, compactness, concavity, severity of a concave portion of the contour. That's also very, very important. Next is symmetry, and you have all those different things. And if we talk about the classes, which is very, very important, we have two different classes. So all the attributes that we have, all the samples we have, they belong to either they are malignant or they are benign, means non-cancerous or cancerous. Right, so we have different classes. Statistical summary is also going to be printed out by using .descr. As you can see over here, what we are getting is mean value, which is minimum and maximum mean value for radius, texture, and all these values. They are already been quantified. So as you can see over here, the numbers are there, and it's very, very important when you do logistic regression. You need to have that numerical data. It works really, really good. If you have yes, no, or some kind of other parameters, you can convert that data into more quantifiable data. So you have all that basic information, all the statistical analysis. Even standard error is given, mean value is given, Next is what you have is, okay, here you can see if there is any missing attributes, that means missing value was there. So no missing attributes are there. Next is class distribution. I already told you that there are two classes, right? Malignant and benign. And this is telling us how many samples are malignant over here, and how many samples are benign. Benign means non-cancerous. So you have 357 and 212. Okay, so who was the creator? Dr. William H. Wahlberg and W. Nick Street. And then third, Olvi L. Mangasarian. So that's the creator of this particular data set. Donor is also been mentioned, date is also been mentioned. If you want to check out this particular data set, you just click on this link that is being provided. So link is also been provided for that particular database link, and you can download that Excel sheet also. Look, so this is the data set that we are using. You can download from here, and this is the machine learning UCI machine learning repository from where you can download. And if I click on this one, I immediately will get a zip file, I guess. Right, so this is the detailed information about the data set, and these are all those variables. Just this snapshot of that. A lot of other information is also been provided, and as you can see over here, I got the zip file. If I unzip, extract it right over here, I should be able to see the data inside that, right? So that is the data we are using, and we don't have to go through this particular route, but if you want, you can also follow that. So this also tells a lot about this particular data set that you can read. References are given over here, and if you want to use this data set, I think you need to definitely cite these references in your publication, because it's very, very important when it comes to citing the contribution that is being done by the researcher. So please cite these references, and these references you can get with that description method we are following. So we got the detailed information, which is really, really good. Right, we got the detailed information on the data set. Now let's move further and see what we need to do. This provided us detailed information about the feature, classes, dataset characteristics, and now it's time for us to maybe better understand the dataset. So now what I'm going to do is I'm going to apply the pandas data frame and create pandas data frame, because sometimes it becomes very handy when you convert your data into pandas data frame. So I'm going to use this code, and as you can see over here, I'm creating the data frame, and data frame is getting created from the data right over here. And further, what I'm getting is I'm creating the columns, because I need to create all the columns, and column basically are the feature names. All the feature names that we have are the columns for our pandas data frame. I'll show you the data frame later on, but let's do another thing as we need to actually now label the data. So whatever we have already labeled this as benign and malignant, but we need to label them differently, 0 and 1. So that becomes very, very handy for the algorithm to actually analyze better. So I'm going to create the label for this particular data set, and these are the targets. So in this case, malignant and benign are the labels. So I'm just creating the label for that. Now what it is doing is the target value it's putting, which is 0 for malignant and 1 for benign, like that, right? Okay, so next is let's do some little bit exploratory data analysis on our data set, so we can see what kind of data we have. So we'll start with printing the first 5 rows. I hope that is clear from the previous course, that how we print first 5 rows of our data. So this is very, very simple, data underscore frame, that is the name we have given. Dot head gives us top 5 rows, and tail provides us last 5 rows. So as you can see over here, because you have multiple features, so it's going to be compiled in this way. So you have serial numbers over here, the index number, and then you have features, and those features are going to on and on because there are so many, right? So you'll say, okay, fine, my data set looks good. Now let's print out the last 5 numbers, or the rows for the data set, or the data frame that we have. And as you can see over here, and I can clearly see 568, that is the number we have. Last 5 rows, they are also being printed out. Okay, so this is good. If you want to see the numbers, you can also see, but sometimes you have a lot of data, so you don't want to look into that one. Let's go and do something else. In this one, what I'll be doing, I'll be getting some information regarding the data set shape and number of instances and features. So let's get all three values like this. By using simple line of code, what you can do is you can get the shape of the data, instances, how many instances we already know, but it's a good idea to get the instances and features. So you can get by using the simple code, because we have already divided those with different columns. So you can extract those columns and then simply print them out. So as you can see over here, it's calculating all those numbers and data set shape. That means we have the pandas data frame that we have created and how many rows and how many columns are there. So in rows 569 and columns 31. Why? Because features are 30. The first one is for the index, and right over here 568 are the samples and the heading is the extra row. Next is number of instances, that okay, how many samples we have, 569, or how many rows we have, how many features we have, 31 features we have. So that provides us detailed summary of our data, and we don't have to open anything to know all these things. Now let's get the detailed information by typing dataframe.info. In this case, you will get detailed information on the data, right? So as you can see over here, we are getting a lot of information about our parameters, but at the same time, what it does, it gives you that what kind of data type you have. So you can see float values are there. If you have any kind of non-null values, so you can also see they are non-null values. So that means it's good. Next is what kind of data set you have here. You have the label which is 0 and 1. It's not a float, it's integer. So that is why you can clearly see that this is the detailed summary. Next, what I'm going to do is I'm going to also get information on the missing value. So let's check on missing values. So here what you can see is if I run this, I'll get another column which will tell you don't have any kind of missing value in all these features, which is good. Already told you this data is very, very clean, so you don't have to be worried about that. If your data that you are creating by yourself, then you might you need to apply some transformation on the data and maybe add those missing values. Otherwise, it's going to be very, very difficult for you. Now let's get the statistical summary of the data. As you can see, we got standard deviation, we got minimum, we got 25th percentile, 50th percentile, 75th percentile, maximum values. All those things are there for every single rows. As you can see over there, they are being provided for all the features. So this is really, really good. And you can get a good idea about if you want to know what are the values, what is the statistical summary. So this method provides you statistical measure for each column. That is what you are getting. All right, let's get another value, which is the distribution of target variable. In this one, what we are getting is how many malignant or benign samples are there. So as you can see over here, how many for label 1, how many for label 0, and you have for benign, I guess 357, for malignant you have 212. So it's kind of like higher side for the benign, but it's fine. But you have significant amount of values for both of them. So I think we are fine. But if you increase number of these values and make a comprehensive data set, what will happen that machine learning algorithm is going to train well, but it's important that the data that you provide is high quality data. Okay. All right, so as you can see over here, we have benign cases, 357 that I've already told you, and the second one is 212 for the malignant cases. Now let's do another thing, which is grouping by label so as to compare the feature means. So what I mean by that is, in this case, what I'm going to do, I'm going to group by these labels, and as you can see over here, this is providing you detailed information on 0 and 1, because I'm grouping them based on the label, and then you can get a kind of idea that where the values are going. For example, mean radius is 17 for this mean radius, and it's 12. So you'll get an idea that okay, whether this particular feature is important. As you can see over here, there is slight difference over here also, but there is huge difference in the parameter. So that means I think this is one of the important parameter that we should be taking. In the mean area, you can see significant differences there, and all of them show a kind of difference between the values. So this is very, very important exercise. This provides you a lot of information on what kind of data you have, whether the data is good or not, right? Okay, so next let's do some data visualization. And data visualization, I'm going to just plot one simple plot right over here. I'm going to use a code that we can, let me zoom out a little bit, code which will create a bar chart. It will show how many values we have for malignant and how many values we have for benign. It's a simple way to actually see the data and see what kind of plot we are getting. So this is the plot we are getting. Let's zoom out a little bit. So as you can see over here, distribution of malignant versus benign tumors, where you have 357 data for class 1, and class 1 is benign, malignant is class 0, and you have 212, right? So you have, if you want to showcase these things in your papers, you need to create those publication quality plots. It's just the simple plot I've created. It's not a publication quality, but if you want to know how we can create publication quality plot, then you take the course that I've created on data analysis. Please, on Research Goal, you'll find the course and you will know what kind of you will know how we can create amazing plots, really publication quality plots using Python programming. Right? Okay, so as you can see, this is very clear. We already knew about that one. Next is I'm going to plot a very important plot that I usually do with my machine learning projects, which is correlation plot. It's very simple code. As you can see over here, using PLT, I'm creating this code. If I run this, I'll get a very comprehensive map of my entire data. I have to again zoom out a little bit so that I can fit in everything. It's a big plot. Let me show what this is. This is the feature correlation matrix. What we have over here is we have created a correlation matrix for our features. So features are running in y side or the left side, and also on the bottom side, right? And those values, they are telling us how much these features are correlated to each other. So you can see over here where you see the red in this particular chart, you will see that they are more correlated. In this way, you can decide whether this feature is important or whether this feature is not important. So as you can see, I have a lot of red values for these features. Probably this is mean texture and mean perimeter. So mean radius is highly correlated. And then we have other parameters also. I have to go down and see what are those parameters. So it's very good data set. I can see a lot of red values. I can see some of the blue lines. So that means they are not that correlated. Right, based on that, you can take a call and you can remove the variables that you think are not important. It's a very good measure, and you can have these kind of plots in your publication. They are very good to visualize, and they give you a good idea that how your the entire data is being related to each other. So this correlation heat map is going to show the relationship between features. Highly correlated features might be redundant and should be removed. Sometimes you'll have highly correlated features. They may be redundant and you need to remove them. They should not be like that. Very highly correlated. Features highly correlated with the target are likely good predictors. So that is also we need to understand what kind of features we need to actually put in our data for training, and what kind of features we need to take care or we need to remove from our data set. So the next what I'm going to plot is the scatter plot, and I have to zoom in for that. This chart was very big. This is not that big. So in this one, what I'm doing is I'm creating the scatter plot of my data, and I'm putting the label 0 and 1 for my different classes. And as you can see over here, this is mean radius versus mean texture. So depending upon what kind of features you want to see, whether they are where they are falling, what kind of separation they are getting, scatter plot is a very good measure to actually identify those things. So as you can see over here, this is clustered around here, and this data set is clustered. This is dark blue data set is clustered over here. So as you can see over here, this is class 0, and you have a very discrete zone that you're seeing over here, and this one right over here. So I think this is very important for our machine learning algorithm classify between these two classes. So scatter plot help us visualize how features separate the different classes. So that is why I'm just creating scatter plot of only 2 features. You can do the same with so many, because now, right, you just need a simple line of code and you can create multiple scatter plots and visualize how the features they separate the classes. We can see in this one, malignant tumors, they tend to have larger radius and texture values. So as you can see, malignant one seems to have larger radius as well as the texture values. So that I think is very important for our data set. All right, so we can also create another kind of plot, and I'm not creating, by the way, the final publication quality plots. I just doing the exploratory data analysis. That means I'm just checking where the data is going, what kind of relationship is there in the data. And in this one, I'm just seeing the box plot of different labels. We have different classes, and then mean radius. So you can immediately see whether the mean radius is very important, and when you're taking mean, and you can clearly see a few outliers over there, and you have a lot of outliers over there, so they might affect your analysis. But when you have less outlier and we have a lot of difference, that means that is going to contribute significantly to your machine learning exercise. So as you can see, box plots show the distribution of features to each class. They help us identify which features have different distribution between classes. So box plot is also another measure that you can use to actually plot and your features, and that gives a lot of insights. And they will also tell you which feature is contributing how much to the machine learning algorithm, right? All right, so I think in this module, we have covered a lot of different things. We'll do data processing in the next module, okay? Please do the exercise by yourself. The code is also available, script is also available. What you can do is you can open up your own script and follow and run these codes. You will immediately realize that how easy it is to actually do all those things. And at the same time, you can also improvise by using AI and then, read the information that is available on machine learning. And if you have a specific different data set, you can follow all these things on your data set. It will be super easy, right? And if you find any issues, please let me know. Join the WhatsApp group and let's connect over there. All right, I'll meet you in the next module for data processing.